All right, topic 6, going to go over the practice problems for this topic. This is looking at using units, looking at how units interact with each other when you're making calculations, using units to help determine what the correct calculation is that should be made, and as well as doing calculations involving powers, which function similarly to units. So read through that information, but starting with practice number 1, we have a factory can produce 80 devices per day, and we're looking for the correct calculation to find how many days it will take to produce 400 devices. So we have kind of all the possibilities as far as multiplication and division: 80 times 400, 80 divided by 400, or 400 divided by 80. And if you're not able to figure out easily which of those to do, it can help to put the units. So 80, look at where the 80 came from, 80 devices per day. That would be written as 80 devices per becomes the fraction. So devices per, per 80 devices per day. And if I multiply that by, it's 400 devices here, by writing the units, this tells me this calculation is no good because I don't want to have devices times devices. The unit resulting from that, from devices per day times devices, would be square devices per day, which is as nonsense as it hopefully sounds to you. So that is no good. We're not looking for square devices per day. So next, 80 divided by 400 would be 80 devices per day. And then when we divide by 400 devices, you could look at that as times 1 over 400 devices. This now means that the device units are going to cancel out. So that's good. We want that to happen. But there's still a problem here. This would be per day, would be the unit. And you should never have a per unit if there's not some other unit to begin with. So it'd have to be something per day, and there is no something left. So that's also no good. Here, 400 divided by 80 would be the 400 devices divided by 80 devices per day. And when you divide by a per something per something, it flips it around. So the day is now so devices, so divided by devices per day becomes devices times day over device. So the device unit cancels and we're left with days, and that's what we do want to have happen. So it would be 400 divided by 80 is 5, and the unit on that is days. The next example, similarly, a vehicle is traveling at 55 miles per hour, and we're looking for the correct calculation to find how far it will travel in 3 hours. So 55 miles per hour, so we'd write that miles per hour times 3 hours. The hour units cancel, and we're left with miles. That's a good unit to answer how far it will travel. This is this will work. This would be 165 miles. If we try to do any of the other calculations, 55 miles per hour divided by 3 hours would be 55 divided by 3, but it would be miles per hour times 1 over hour. So the hour would go to the bottom because it's divided. That resulting unit would be miles per square hour. Again, no good. Not a unit that makes sense at all. Then 3 divided by 55 would be 3 hours divided by 55 miles per hour. So the unit on that would be hours divided by miles per hour, which would be hours times hour per mile. So again, this would be square hours per mile. Also no good. If you do know the calculation to do writing with the units, then you can kind of get the hang of seeing how the units should interact and what works and what doesn't. So that then if you do get to a question that you're not sure what calculation to do, then you can use the units to determine that. So again, you could do the reading on your own, but next practice, we're doing scientific notation calculations. And the idea is to learn how to shortcut this so you do not have to write this out in standard notation to do the calculation. You just do the calculation in scientific notation. So we group the numbers. So 6.1 times 9. And then this is 10 to the third times 10 to the seventh. Then we add those powers. So it's 3 plus 7. 6.1 times 9 is 54.9. 3 plus 7 is 10. But we have an issue here. This is not scientific notation because the number part is 2 digits before the decimal point. So to fix that, move that decimal point 1 place. It was too big of a number, so it needs to actually be a higher power of 10. Move the decimal point 1 place, add 1 to the power, and it is 5.49 times 10 to the 11th power. Then for division, similarly divide the numbers. This fraction is division. Those are interchangeable notations. So 1.8 divided by 6, and then it's going to be times 10. And for division, it's power of the top minus power of the bottom. So -4 minus -7. So the negative is part of the 7 there. It doesn't replace the subtraction. So it's not just -4 minus 7. It's -4 minus -7. And that is -4 minus -7 is -4 plus 7, which is 3. If you want to put that into your calculator, you need to use your negative button and then the 4, and then the minus button, and then the negative button, and then the 7. Excuse me. So 1.8 divided by 6 is 0.3. And that's times 10 to the third. And this one's just standard notation. So I'm just going to go ahead and move that decimal point 3 places, or multiply 0.3 by 1,000. Comes out 300. And then the last example here is a word problem. So we have a water desalination plant can produce 2 times 10 to the 6 gallons of water in 1 day. How many gallons can it produce in 8.6 days? So the first thing here is to figure out what calculation needs to be done to combine these numbers. So I'm going to start by writing the 2 times 10 to the 6th. And that's gallons of water in 1 day, or in other words, gallons per day. Now I want to look, if I'm trying to find a number of days, this doesn't work. I'm going to have to divide by this in order for the days to end up on top. But I'm looking for how many gallons. Gallons is on top here, so that's all good. So then the 8.6 days, to get rid of the per day, if I multiply that by the 8.6 days, then the day units cancel. So to get the number of gallons, I'm taking 2 times 10 to the 6th times 8.6. And again, there's no need to write that out in standard form, that 2 times 10 to the 6th. I can just do the calculation of the 2 times 8.6. And that is 17.2. And that's going to be times 10 to the 6th. But again, we want scientific notation. And this is 2 digits before the decimal point, not scientific notation here. So I need to move that decimal point. So I need it to be 1.72. When I move that decimal point, I have to balance that by changing the power of 10. In this case, the number was too big. I moved the decimal point 1 place to correct that. I'm going to add 1 to the power of 10. So it's 1.72 times 10 to the 7th.